morning, 7th graders. What I'm posting here is going to be a video where I go through and I review information that I saw across the board, lots of scholars getting incorrect or having misconceptions about on your study guide. So to get us started, I do want to first review when is your midterm. Your midterm is going to be this Thursday, February 2nd. It'll be the first thing that you do when you come into the building. You'll come in, go to advisory, and then you'll jump right into your science midterm. What is a science midterm actually going to look like? It's going to be about 15 questions. And in terms of pacing, what is that going to look like? The midterm itself is going to be 45 minutes in length to respond to these 15 questions. If you get extra time, of course, you'll also receive your extra time. But for friends who are just taking it the normal 45-minute length, what is that going to look like in terms of pacing? That means that when you get the test, you'll initially have about 3 minutes to preview the length of it and plan how much time you're going to devote to each section. That leaves you 37 minutes, which if you do the math, is about 2.5 minutes per question if there are 15 questions. If there's less, then you'll have more time. If there's more questions, then you'll have a little bit less time to respond to those questions. And not every question will take 2.5 minutes. Some questions may take more time, some questions may take less time, but your proctor is going to be checking that you're actually moving along with some urgency and you're not devoting 10 minutes per question, etc., etc. At the end of the test, you need to leave aside 5 minutes that you can go back, check, and revise any of your work, check to make sure you included units, check to make sure you included titles, etc., so that you're not losing those simple, easy points. So when your proctor is proctoring, they will make sure that you have 5 minutes at the end, or they'll be checking to make sure that you have set aside 5 minutes at the end to go back and check your work. So what we're going to do now is we're going to move down to the actual questions that you saw in your study guide, and across the board, what did I see in terms of trends that 7th graders had when responding to the questions. So what we have here, your very first question is a question that requires that you interpret a model and apply your knowledge of boiling point and melting point. So you'll notice that throughout the study guide, I have included some exemplar annotations that I expect you, when you're taking your midterm assessment, to also include. So it says the diagram below shows the motion of zinc particles. The boiling point of zinc is 907 degrees Celsius. I've included an annotation here. I said you have the vocabulary word boiling point here. And so I included as an annotation, anything above 907 degrees, since you're looking at a boiling point, is going to be a gas. It says, and the melting point of zinc is 419.5 degrees Celsius. I also included an annotation here. Since it's a melting point, anything below 419 is going to be considered a solid. Anything above 419 is going to be considered a liquid. I also could have included that annotation. Anything above is a liquid. So with these annotations already written out, I can go now and I can actually interpret this model. So I'm looking at model A, and I've included interpretation. I'm looking at some particles that are far apart. They're taking up the entire space of the container. Based off of that, I can infer that I'm actually looking at a gas here. If I go to model B, I'm looking at molecules that are very close together, it appears. There's not a lot of space between them. But what I do notice is that they're all packed together in a single shape. So they have maintained their shape. They have not taken on the shape of this container. So while they are tightly packed together, and I might want to assume that I'm looking at a liquid here, what is telling me that this is a solid is the fact that they've maintained their shape, right? They're in this cube shape, and that you only see that with solids. Doesn't matter what container you put a solid into, it's always going to be the shape that it was prior. And then if we go to model C, what you're seeing here, what they're trying to show is that these molecules are obviously tightly packed together, but what you're also noticing is that they've actually taken on the shape of the container, right? Because they're so closely packed together, unlike what you see in model A, and the fact that they've taken on the shape of the container, I would describe model C as a liquid. And so a lot of you, when you were responding to this question, thought that maybe B was a liquid and C was your solid, but I think you were just looking at the arrangement of the molecules when you decided that. But since you see that these molecules are taking on the shape of the container, that's what tells you that this is a liquid. And because these molecules have maintained their shape, they're in this cube shape here, that's what tells you that this is a solid. So with that in mind, it says which model best represents the spacing and shape of particles at 634 degrees. So if you go back to your annotations, I said anything above 907 is a gas, anything below 419 is a solid. We're at 634, so we're in between both those numbers. So that's going to fall within your liquid range. And so because we're looking at a liquid, because we annotated model C as a liquid, your response should have been model C. Now, if we move down to question number 2, you're looking at a balloon that's been filled with air. It says the image below shows a glove filled with air at room temperature. What would the volume of the glove be if the temperature decreased? So you're decreasing temperature. So there's a lot of things that happen when you decrease temperature. You know that temperature is a measure of kinetic energy, so you've decreased your kinetic energy. And kinetic energy and temperature tell you how quickly molecules are moving. So we know that the speed at which molecules are moving has decreased. Okay, but does that tell me anything about the volume? Well, you also know that the spatial arrangement of molecules is affected by temperature. At high temperatures, molecules are spaced very far apart. At low temperatures, molecules begin to move in closer to each other and become tightly packed. So based off of the second thing that I just said, based off of what we know about how temperature affects the arrangement of molecules, you would know that the molecules are going to become tightly packed if you decrease the temperature. Because they become tightly packed, they're going to take up less space within this glove. Because of that, you can assume that the volume of the glove is going to decrease. Because these molecules are moving in closer together, they're taking up less space, and therefore the volume of the glove is going to decrease. So it was worth 2 points. You needed to reference number 1, the volume is going to decrease, and number 2, it's going to decrease because the particles are moving in closer to each other. That would have been your piece of evidence to support your claim. If we move down to question number 3, it's a pretty simple question. It just asks for you to develop a graph based off of the data provided. This shows up a lot, these experimental design questions throughout this, and they're pretty easy points. You just need to make sure that you're actually using these checkboxes here to make sure that you're receiving full credit when possible. So it says, number 1, what you need to do when designing this graph is to include a descriptive title. So this is a closed reading issue. This is an effort issue. If you're not including titles and tables or graphs, you will stay for Effort Academy. It's crazy to lose a point because you didn't include a title. That's unnecessary. It's unacceptable in 7th grade, and you will stay for effort. You will stay for detention because you did not include a title. It says next that X and Y axes need to have labels, they need to have units, and they need to be within a logical scale. There are 3 things that you need to include here. It's worth 3 points. They've listed 3 things. Therefore, if you do not closely read this question, you do not respond fully, meaning that you just label your X and Y axes, you do not include units, then you're going to stay for Effort Academy because, again, this is a close reading issue. You're not following directions. You're not closely reading the question. You're clearly not annotating closely enough. So lots of you with this question gave me time and you gave me temperature. What you didn't include were units. Time needs a unit. It could be hours, it could be seconds, it could be minutes. I don't know unless you include a unit. Same thing with temperature. Temperature can be measured in Celsius or Fahrenheit. You need to include a unit when you're giving me a label, such as time, such as temperature. Those are the big things that I saw with this question. So now I'm going to move on to question 5. So question 5, we're looking at a heating graph. It doesn't tell you what specifically we're looking at. It's just a heating graph of substance X. And the question 5 asks, it says, at which point best represents the boiling point of substance X? So you, number 1, need to understand what is a boiling point. Boiling point is a temperature that something reaches once it begins to go through the phase change evaporation. So based off of that, you have options A, B, C, D, E, and F. There's actually an error within your options here that Network did not resolve in time before I printed them. So they already have told me that they know that option D should be a response. should be an option for your responses, but it was not